you need to decide about what you want to do by yourself. But hopefully I give you some sort of the overview. So I will discuss about some of the latest findings, and discuss about some of the methodology, and I hope you're gonna have the active participation in class. That is highly encouraged. Now, when you are doing a research or looking for a topic, you need to get some background information. And the good background information can be from reading the journal, the journal articles. How many of you have read the articles before? Have you been reading the academic journal before in class, in other class? If not, this would be the good start. So today we will gonna read some of the journals together. And I will point you to the direction where you can find the good article to read. Now, in finance, we have different types of journals. But the top journals that you should read is the JF, JFE, and IFS. So these are the acronyms of the top journals. So all the great ideas, interesting findings, they are published in these three journals. And there are some other good journals as well. For example, Management Science, JFQA, Review of Finance. These are the good journals, but it's not as good as the top, but still good. Below that, there are some tier 2. These are decent journals as well. And publishing is basically my career. My work responsibility is to publish research, and we go through the hierarchy. We try the top first. If we fail, we go down step by step. But still, these journals, the tier 2 are still very good articles, and normally they are easier to read as well. So they are less technical and still have an interesting result, but maybe the result is not specific enough, or they are too specific in a certain country, in a certain area. So they are published in these more specialized journals. You can also look at the article in the top conferences, the AFA, WFA, and EFA. So these are the top conferences. And as you know, accounting are basically the sister of finance. We have a very closely related discipline. So a lot of interesting topics in accounting could be your potential topic as well. So I will not rule out any topic that is published in the accounting journal. Also, some of the economics journal are very good. AER, QJ, and so on. So those are basically the reference for you to when you start looking for the topic. You can browse through those journals, and I provide a link to the top 3 finance journal. You can just click on this link, and then it go through the journal, and then you can download the article that you find interesting. I think Chulalongkorn has a subscription, so you should be able to download all the articles there. Now, so what we're going to do today and tomorrow, well, basically I will start with some of the framework or the research process. What do you have to do when you write a research? And there are several good recommendations here as a reference. And when you do any research, you need to do some sort of analysis, number crunching, and that will be based on econometrics. You have done econometric class before, right? Yes. So that's normally a lot of students at this level 5 econometric is very challenging topics, and are quite scared to do this research, partly driven by the difficulty of econometrics. But I have to tell you that the research is not equal to econometrics. The research is about the idea, how to get a good idea and answer, okay, find the answer to that good idea. Okay, so I provide a list of the papers that I hope to cover, but I don't know whether we have enough time to cover all of them. Okay, but I try to give you the main idea of the topic. I try to highlight the interesting methodology, okay, of this topic. So the idea would be we have about 10 topics, and I select these topics based on my personal preference. Okay, it's just the area that I'm more familiar with. Okay, but of course, in your own research, you need to find the topics that you find interesting. Okay. Now, any question at this point? All right, so I will start with the research process then. So these are the general guidelines. Okay, we are not going to embrace anything specific here, just general guidelines. So hopefully we will discuss about how to do research, the format, and you need to find a supervisor, okay, how to maintain, okay, a good relationship with your supervisor. That's the key, okay, because your supervisor will be the one who will influence your success or failure, okay, in your work. So hopefully they will guide you to the success. I always find that whenever I do a research, we have a dark period, okay, a frustration time where it seems to have no success. Okay, I don't see any light at the end of the tunnel, but keep in mind that it's always darkest before dawn, right? So once you pass through that frustration period, and I think right now, okay, you have started to look for the research topic. The frustration is, what is a good topic? Okay, what is a topic that first you can understand, second you want to do it, it piques your interest, and then you can actually do it. It is not economically too difficult. So for your purpose, okay, you need to keep in mind that you have a time constraint. Okay, just like any economic decision, there is a time constraint. There might be some topic that looks very interesting, but it's going to take you 2 years to complete. That's not 2 years that you can afford. Okay, you only have, I don't know how many times you have, 6 months? Yeah, probably 6 months that you can afford. So always keep that in mind. Time management is the key. Okay, so you don't want to be sidetracked, okay, into working hard, okay, but not producing result within 6 months. Your supervisor time is a scarce resource, okay, so you need to use them wisely. Okay, that means whenever you make an appointment to see and discuss with your supervisor, you need to be prepared. Okay, you prepare the set of the question that you want to ask, the set of the question that you need guidance from him or her. And your supervisor is not a babysitter. Okay? They are basically gatekeeper. Okay, so they will say, they will respond to you that, oh, this is a good idea, this is a bad idea. Okay? But they are not supposed to tell you, do this or do that. Right? To do this or do that is your responsibility. You find a topic, okay, throw it to your supervisor, get approval, okay, then he will recommend to you that, oh, that's a good idea, bad idea, or that's too difficult, or you may want to add something more. And the reason is, the whole objective here is, we want you to be able to do things independently, okay, without relying on your supervisor. You are not the research assistant of your supervisor, okay? Because if you are doing everything that your supervisor tells you, so what is the thinking process, right? So we want you to be able to think and do it for yourself. So, and you will see that you probably meet your supervisor. Good student will talk to the supervisor a lot in the early stage. Okay, and then once you learn, once you are sure about the path and direction that you go to, then later on down the stage, you don't need much help from your supervisor at all because you are able to do it independently. The not so good student is the opposite. The not so good student never show up in the early stage and then require a lot of time from the supervisor at the later stage because you are rushed, you don't know how to do it in the later stage. Okay, so try to meet your supervisor as frequent as possible in the early stage. So you learn about the process and can do things independently. So these are the normal steps. Okay, asking the right question, that is the key. Ask the right question. Okay? Research is not about difficulty or the technicality of the math or the econometrics. It is about asking the right question. Right? Keep in mind, it's about asking the right question. And then all these analysis, there are many ways to do analysis. Right? Some way is good, some way is excellent, some way is bad. Okay, so we will try to get some help from the supervisor in this analysis part. But asking the right question is basically your job. Okay? And then once you do this, many students leave the writing until the end. Okay, until next week you need to submit a draft, then you start writing. That's no good. Okay, the writing process should always come along with your research. Okay, when you start to think about the idea, do a bullet point. Okay, what is the idea? Why this idea is interesting? Who has done it before? Why are you different from those literature? Okay, those bullet points, keep doing that. And then when you do the data cleaning, data collection, take note, okay, what criteria you use, what period you use, what are the samples, what are the problems that you find the data. Sometimes you find the missing data, sometimes you find that the data is not right. Keep noting those little details in your notebook. And later on when you write it, you need to put all those details. And then it shows to the reader that you are careful about the analysis. Okay, so it sends a signal that this is a high quality research. So keep note of your work all the time because you will find that it's very easy to forget the details. Okay? So always keep it in the writing. A general structure of your work, okay, should be an abstract, okay, 150 words. Introduction, body, okay, and that body contains literature review, data analysis, result discussion, and so on. And then conclusion and references, okay, these are standard structure. Writing, probably, as I said, is tough. Okay? Even for me, writing is always tough. It's tough because not only it's not your mother language, but it's tough because you need to organize the idea. Okay? You need to think through the whole thing before you have a very good product. And you probably need to keep writing. Never done a last minute writing, okay? In general, the paper that we publish in the good journal, we need to rewrite the paper about 10 times. Okay? So rewrite means sometimes we have just to delete everything, okay? Forget about it and start from scratch. Sometimes we need to add more technical details. And sometimes we need to change the paragraph, position, okay, the argument and so on. So if you do the writing just 2 or 3 times, that means your work is not going to be good enough. Okay? If you just finish the writing, first draft tonight, give it to your supervisor tomorrow, I can guarantee that it's a bad draft. Okay? Because you need to go through and read the writing many, many times. So when you do the writing and any research, okay, Okay, in particular, if you are trying to look for the idea, the good idea. The good idea should have one central contribution. Okay? You can do a lot of things in your research, but ultimately, when your friend asks you, okay, in the elevator, what are you doing in your research topic? You should be able to say, oh, I'm doing this. And that is one central noble contribution. Okay? Research is about contribution because why bother doing research if, for example, you already know the result? Okay? So that's why a lot of replication work doesn't have much contribution unless you are able to identify why you have contribution. Some replication work has a merit, but a lot of them don't. Okay? So be able to say what is the contribution. And when you start writing, a lot of students, they are not very specific, okay, in writing. They are trying to fluff, okay, the writing. The way fluff means that if you need to ask your supervisor about how many pages should I write, how many words limitation should I have, that's no good, okay, because that means you have a tendency to stretch, okay, or fluff your writing to meet that threshold, okay. Good writing is always very detailed, very specific, and don't worry about those limitations. It doesn't matter, okay, it doesn't matter at all whether you have 10 or you have 100 pages. Actually, the more pages you have, the tendency that you repeat things, the tendency that you extend things for too long, and it's going to be a boring writing. Okay? So, when you read something like this, I analyze data on executive compensation and found many interesting results. What do you learn? Imagine you read it. Okay, and this is a very standard sentence that a lot of students wrote in their report. Nothing, right? Because it does not convey any information, and that's why when you write it, and when you reread your work and you find some statement like this, keep asking yourself, what does it contain? What are you trying to tell the readers here? If it's not containing information, these are redundant, right? You should delete it. You should make it precise and concise. Example of a very good writing, these are Pharma, okay, Eugene Pharma. Do you know Eugene Pharma? Okay, he is the Nobel Prize winner, okay, and he is a very good writer. And this is his abstract. To easily measure variable size and look to market combined to capture the cross-sectional variation. Contain a lot of information, right? Precise, contain a lot of information. And these are what he does, what he did in his work. Okay, so this example, I'm trying to highlight that every writing needs to have a purpose. Okay, don't just keep writing for the sake of writing, for the sake of having 5 pages, 6 pages, 7 pages. No. Every statement needs a purpose. Okay, that's why when you do the writing, you need to have a skeleton, right? Paragraph 1, what is your objective? What is your purpose? Paragraph 2, what is your purpose? Okay? Have the skeleton first, and then fill in that skeleton. Okay? Then you know what is the objective of your writing. Don't just keep writing. Again, in the literature review, a lot of students do the literature review this way. You read a paper, you summarize it, you put it in a paragraph. Then you go and read another paper, summarize it, put in a second paragraph. That is useless. Okay, because we don't want you to summarize the literature for the reader. Okay, what is the purpose of the literature review? The literature review should always connect to your work. Okay, how is your work related to the literature? Is that your work trying to argue something different from the literature? Or your work trying to point out that there are some flaw in the literature? Okay, or your work is opening something totally new. Okay, but still, even it's totally new, it needs to, every great man stand on the shoulder of the giant, right? So we need to build on something. Okay, what is you are building your work on? So that means every literature should be able to connect to your work in one way or another. Do not write a literature review in isolation. Okay, because in isolation, no one knows about why you mentioned about this paper. Okay, how do we get to the central contribution? You see that this is the word, distill. It means that it goes through many processes, right? Many thought filtering. Okay, so it's hard. In other words, this implies that it's very hard to ultimately come up with a simple contribution. When people say complicated things, you should understand that they don't understand. If you don't understand things, you tend to make things more complicated than it is. Okay? So, to show that you are the master of your topic, think about it a lot. Talk to your friends. Tell your friend about your contribution. Tell your mom. Okay, maybe your mom are interested. She might be interested to know what the heck you are doing, right? If your mom understands it, that's good. That means you fully capture the essence of your topic because you can tell the layman. Okay, they understand non-technical terms. They understand your contribution. All right. If you can't, then you need some thinking about how to make it simple. Yes, simple is the best. Right? Simple is the best. Put yourself in the shoe of the reader. When you read a academic journal, how do you read it? Well, I'm pretty sure, 100% sure that no one read from start to the end. Okay? You're probably going to read the abstract, a few paragraphs of introduction, and then you start to get hazy, and then you need to move on and skip, right? And then probably come back to read conclusion. So you need to understand the nature of the reader. Everyone are busy. Your supervisor is busy. The committee is busy. If you send a paper to the journal, the referee are busy. They don't have time to read everything. If you make it complicated, if you make it boring, they're not going to read it. They're going to have a bad impression. And impression is everything. Okay, once bad impression forms, they're going to look at your paper in a very negative way. Okay, so you need to make sure that you can cater, okay, the nature of the readers. So that means abstract is absolutely important. Introduction is absolutely important. The other part is not so important. Okay, in terms of the writing. The first few paragraphs, probably I would say the first page of your introduction is the key, right? It's just like the reader open it, read the first page, and they have in their mind, wow, that's interesting, I want to read more, I want to know more. If they read it, the first page and, oh, I don't understand, okay, why you do this, why you do that, then they have a bad impression on your work. So, how to make it interesting? Okay, only a few care how it is different from others. Only a few cares whether it's go up to different variable definition, different instrument set. So that means the way you tell it, you need to tell the big picture first. You may do a lot of robustness check. You may do a lot of different sample periods. You may try a lot of different methodology. You may try different sample size and so on. But that doesn't matter. For the reader who first read it, they just want to know what is the big picture. Show them the forest first, okay, before you show them each of the trees. And the style, okay, the writing style is quite important. We need a newspaper style when you write your research. Of course, it's not a newspaper article, but the writing style should be the newspaper. What is a newspaper style? Newspaper needs catchy phrases, right? Needs something that piques the reader interest. Okay? So that means you need to bring the most interesting part of your work first. Show them first, show the best thing first, so that the reader is interested. Okay? And then you fill in the details later. Do not write it as a joke or a mystery or a suspense thriller book. When you know who is the murderer in the last page, right? That's how the suspense has been developed. So all the solution is shown in the last chapter. That's not how you should write. The most interesting thing comes first. All the details come later. Again, the reader do not stick around to find the punchline. Okay, the punchline is the key result, the main result in table 12. The main result should come in table 2, okay, or in table 1. Right? That's how you should write your work. And many students wrote it as the travelogue. What is a travelogue? The travelogue is when you document that, oh, I start by doing this, it doesn't work. I change my specification to this, it doesn't work. I add more data, and then later on it's work. Okay, that's a travelogue. So travelogue is something like a linear timeline. Okay, so you write a paper by telling, okay, I do this one first, I do this one second, the third, the fourth, the fifth, and what is the key result is in the sixth step. No, don't write it that way. Don't write it as the linear timeline of how you work. Reader doesn't care. Okay? We don't care how you came to figure out the right answer. We want to know the right answer. Okay? Present the right answer first. Keep all different things, 100, 500 different things that you do and doesn't work. Put it in your diary. Okay? Document your frustration and so on. But don't have to show to the reader. Okay? The reader just want to see the best product, the right answer that you find. Any questions so far? Okay, the abstract 100, 150 words. Okay, and don't mention the literature in the abstract. This is the prime real estate area. Okay, 100 words, this is not long. So you should present the best thing. Okay, don't fill it with all the non-important detail. Okay, and with specific data are analyzed, theorem are proved, discuss is made. That's an empty word. Okay, it has no information. Okay, introduction is the most important part. Okay, and there are different ways to write introduction, and it is always very difficult to write introduction. But there are a few tips that we would recommend. Introduction is not a conclusion. Okay, so do not start your introduction by telling the reader about the result because the reader have no idea about why you do it. Okay, why it is interesting. Do not start your introduction with philosophy. Many of the students use philosophy. Financial economists have long wondered if the markets are efficient. Right? The finance literature has long been interested in financial market integration. Don't do that, okay? Because again, this is too broad, too abstract. The writing should be very specific, okay, on what you do, why you do it, why it is interesting. All of these philosophy, okay, is known to writer as clearing your throat. What does it mean, clearing your throat? When you listen to someone, right? When someone present the work, they say, this is clearing your throat. It wastes off the space, it wastes off the reader time, and the reader who lost interest in your work very quickly. Always start with your central contribution. Okay, we have touched about the literature review, but the point that I want to emphasize is literature review must be related to your work. Only include the paper that is related to your work and tell the reader why is that paper or article is related to your work. In what way? Okay, that is a literature review. Another thing is the citation. Okay, try to be generous, okay, and cite as many papers as possible, okay, if it is related to your work. Okay, the body of your work, it should be the most important result first. Okay, that's basically we already discussed that. The theory, if you are doing something like the theory, then you should have some reason. Okay, the theory should always come. Okay, recommendation should always come with the empirical work because the theory ultimately try to help the reader to understand how the world actually works. Okay, so the theory would be only meaningful if the model that you propose actually explains the data. If you do empirical, okay, you should start, okay, with the main result. A lot of students do the warm-up exercise. What is a warm-up exercise? The warm-up exercise is presenting descriptive stats. This variable has a mean of this, median of this, standard deviation of this, characteristic is normally distributed or not. This is a warm-up exercise. And it is a distraction to the reader. Because the reader is unsure why would you present this descriptive stat. Okay? If you are working with the well-known data, okay, data that has been done in 100,000 of research, descriptive stat is not necessary. Okay, skip it. Or if you want to present it, put it in appendix, okay? Or put it in some reference that you can show if someone asks, but never in the main result. Unless you are doing with the data that is new. You are the first one who create this data and collected data. Then, yes, descriptive study is useful because it tells the nature of the data. If the nature of the data is already well known, don't present it. Okay, you will mightily resist this advice because we have the idea of I already done it. let's put it. Let's show that I have a comprehensive work. Show to my supervisor that I have 50 different tables. No, that is not a good research. Okay? Because those 50 different tables, they are disconnected, they present here and there, bits and pieces, no connection at all. So you want to present a coherent story, okay? So think hard about what is your key result, put it first. Get the rest, go to the appendix. And ultimately, the appendix will go as well, because ultimately everyone already knows about the nature of the data. We don't need that information. And the rule is, if you want to put any table before the main result, that table should only be the table that helps the reader to understand the main result. Okay, the idea is always main result comes first. Conclusion. Conclusion should be short and sweet. Okay, short and sweet. I heard some recommendation that conclusion is a rewritten of your introduction. No, don't just rewrite the introduction here, because we don't want to put redundant words in there. Okay, so if you just rewrite the introduction, then we already know about it. Okay, so that's why a lot of good writing, conclusion is very short. Okay, just summarize what happened, what are the implications, what is the next things to look forward to. Okay, what are the shortcomings of your work, what are the limitations. Okay, so we should have information in every of your writing. Don't repeat it, don't make it redundant. Okay. When you talk about conclusion, sometimes you speculate. Okay. For example, you may say that if we are able to extend the data more, then we might be able to prove this and that. Don't speculate. Okay. When you write, so the reader wants to know your fact. Okay, not opinions. So try to make sure that they understand what is a fact. Appendix, okay? Good researcher, they have little appendix. Because they already weed out all the important things and only include important things in that paper. They don't worry about the sunk cost. What you have done, you learn corporate finance, right? Sunk cost. You already produced that table, sunk cost. Don't be afraid to cut it. Okay, if it's not important, cut it. Right? So it makes your work tidy. Okay, it makes your thought clear. The reader see a clear, tidy idea. That is good. Okay, don't clutter by put in different tables, vary a little bit, put in a new table, vary a little bit, put in another new table. Or even you put in appendix. Ultimately, good writer, okay, only have a key table. And all these, you can even dump them out of the appendix too. Right, so these are some introduction on the process. Obviously, you may not go through this process now, okay, but sooner or later you're gonna go through. So it's good to give you some guidance here. Doing research is similar to trying to learn how to bike, okay, or learn how to swim. I can't actually teach you to swim. You can swim by yourself. I give you the guidance, okay? You do a good research by yourself, right? Ultimately, it's you who learn how to do it. I only hear, and your supervisor, I only give you the guidance. Any question about the process? So this is a very general process, and of course it applies to any type of research, not only financial research. So we're going to go a little bit more specific now, okay, on topics here. And as I said, we have 10 different topics. And probably I will spend a substantial amount of time on econometrics as well, because I think understand the good econometric is very important to do good research. Okay, so I will go a little bit on econometrics at the start, and then we proceed on to the ideas. How many of you find econometrics difficult subject relative to the other courses? All right, so majority find very comfortable with econometrics, right? That's good to hear. So the topics, okay, these are the list of the topic, and as I said before, these are the topic that is in my research area, okay? And I have to apologize that I'm not a corporate finance guy, so I only have one slot for the corporate finance. But corporate finance is a big topic, okay? It's a big area. And if you are interested, then you should read more. So I'm more of an investment person. But anyway, one of the topics that I will start with is causality. Why causality is an important part? Well, it is important part because a lot of regression analysis. Regression is the backbone of research, right? And we derive conclusion from looking at the regression result. But you need to understand that 99% of the regression, they are telling you about the correlation. And you may heard the word. Correlation is not causation. Okay? Simply you see correlation, it doesn't mean that the causation is there. Why? Well, for example, if you see the what should be example? If you look at the amount of, say, garbage, okay, maybe in Thailand, right? Garbage in Thailand over time. So amount of garbage over time go up. Then you look at the Dow Jones Index. Dow Jones Index over time go up as well, right? So you run a regression between time series regression between the garbage year by year with the Dow Jones Index year by year. What do you find? Well, you find a significant slope, significant result, right? So what I'm telling you here is we are using the Dow Jones Index here, and then you run a regression with the garbage. In Thailand, over time. And you would normally find that you reject the Dow policy. The beta is significant. But do you really believe that the garbage in Thailand determines the Dow Jones Index? No way, right? Thai is too small. Thailand is too small to have any great influence on the Dow Jones Index. So what does it tell you here? Well, you run a regression. You are asking whether these two variables, Dow Jones Index and garbage, do they have correlation or not? But computer is quite dumb. You ask them the question, they always give you the answer. But you are asking the wrong question. The question that you want to ask is whether they have any cause and effect. Okay? But this sort of thing, this sort of regression, it tells you the correlation only. Okay? So that's why always keep in mind that causality is a big thing, okay, in the financial research, and actually a very big thing in social science research. Okay, any area in social science you need to be worried about causality. All right, we will talk more about what is causality issue later on. But just like any analysis, okay. The analysis should be based on the data. So you need to collect the data. After you collect the data, so you have different observations, right? You try to estimate the data. Okay? Based on the data, you estimate them. So what is the estimator? Well, estimator is, for example, you have the data of yearly return. The estimator is the average return, right? That average return is your estimator. Now, keep in mind that estimator is a random variable. But we hope that whatever we estimate, in this case the average return, we want to tell that the average return is our parameter. Okay. But unfortunately, parameter is constant and unknown. Okay, you do not observe parameter. You can only see estimator. So you use estimator to proxy for parameter. Okay. Now, our research, okay, try to make the conclusion based on the estimator because we make assumption that estimator is equal or is equivalent to the parameter. Sometimes it's true, sometimes it's not. Okay, so need to be careful that estimator, okay, is a random variable, but parameter is a constant term. And if you read the academic journal, they normally use the Greek symbol to represent parameter. So, how would you do the parameter estimation? Okay, if you do the econometrics 101, they normally talk about 3 different techniques. Okay, but the majority of research, I would say about 60% would based on the least square techniques. Okay, the OLS. Some other advanced one do the method of moment, the GMM, okay, general method of moment. Some do the maximum likelihood. Okay. So that depends on the nature of your research. But majority, more than half, gonna simply use the least square. So I'm gonna give you some idea about what are the different of these 3. So let's assume that we are tossing a coin 10 times. Okay, and then the head show up 6 times. So what is the probability of the head? Okay, what is the probability of the head in this coin? So we are interested in this theta. So this theta is parameter. Okay, it is a parameter. We have the data. Okay, the data is to tossing a coin, and you record that the head show up 6 times. So how do we make a statement about our parameter? You may think that, oh, this is very easy question. Of course, you throw it 6 times, head show up 6 times, so it should be quite 6, right? 6 over 10. Okay, but I will show you a little bit more formal way to analyze it. So we are trying to estimate theta, and there are many ways to do it. The first one, the method of moment. The method of moment is very simple. Basically, the idea of the MOM, method of moment, it is part of the GMM. Okay, is basically whenever you see expectation of anything, for example, expectation of X, the idea of the method of moment is to transform that expectation into the summation divided by n. Okay, that is the idea of the method of moment. Anytime that you see expectation, transform it into summation divided by n. So let's see how we use the method of moment to answer this question. Well, let's assume that X is the result of each toss. So you could have 1, 0, okay, differently here, but basically you only have 6 of the 1. Okay, you have 6 of the 1. So 1 is for head and 0 is for tail. What is our equation of interest? Our equation is this one, expectation. Okay, expectation of x equal to the theta. That is our key. Okay, so the method of moment will be based on expectation. Expectation of x equal to theta. You change expectation into summation divided by n. And you can sum x. X take the value of 1 or 0. You sum all the x, then you get equal to 6. Okay, divided by n equal to 10. So your theta equal to 0.6. So the way that you see the question and you come up with the 0.6, in your head, you do a quick method of moment approach. I think most of you do a quick method of moment approach. And that is here, summation of x divided by n. Okay. Any question on the method of moment? Then some estimation can be based on the maximum likelihood. Now, maximum likelihood is a little bit detailed, but it is not difficult. The key point of the maximum likelihood is you need to understand the distribution of your variable. For example, in this case, coin tossing. Okay, coin tossing follow the binomial distribution. Okay, so it's the theta to the power xi multiplied with 1 minus theta 1 minus xi. That is the nature of coin tossing. So any variable of interest that have only 2 outcomes, yes or no, pass or fail, 1 or 0. If your outcome variable can only be 2, okay, 1 or 0, only 2 outcomes for that variable, it will follow binomial distribution. Okay? For example, you an airline, okay, booking, so it will be customer showing up, customer not showing up. Okay, the restaurant booking, customer come, customer doesn't come. So these are examples of the binomial. The key point of the maximum likelihood is what is the likelihood? Okay. So maximum likelihood, we use the term MLE. Okay, maximum likelihood estimation. The key point is what is your likelihood? Okay. And the method of moment, the key point is what is your expectation? Right? The key point of maximum likelihood is identify the likelihood. In this case, the likelihood is binomial distribution. Because it's only 2 outcomes, 1 or 0. Sometimes you can have a normal distribution if your variable is continuous. Okay. After you are able to identify the maximum likelihood, then how would you maximize it? This is the likelihood of one event. If you do it many times, then you multiply, assuming that each event is independent. So the probability of all events equal to P1 multiply P2 multiply P3 multiply to Pn, right? So these are, of course, assume that each event or each of your throw, each of your tossing, they are independent of each other. If they are independent of each other, the probability of the whole, you throw it 10 times, okay, you toss it 10 times, then you just multiply P1 to P10. And that is the multiplication symbol, the pi here. Okay? And we try to maximize the likelihood. Okay, maximize the chance that this event occurs given the probability. So if you want to maximize something, okay, what you can do is you can do a derivative. For example, you have a function y and function x. It could be a complicated function like this. Okay. The question is how to find x that maximize y. Okay, and this is the maximum likelihood techniques, because we are asking how to find theta that maximize the likelihood. Right? We have a likelihood function. We are trying to find the value of theta that maximizes the likelihood. How would you do it? Conceptually, how would you do it? Well, you know that human is very good in processing visual information. You see a graph like this, you know that, hey, possible maximum is here. Easy, right? Because you see a graph. But what is the process in finding that 2 point? So you need to notice that at this point, what happened? The slope of the graph equal to 0. Okay? So at the maximum, but of course at the minimum the slope also equal to 0 as well. So that's why when you look at the slope, you should check the concavity and convexity as well. Okay? If the slope at the maximum, slope go from the positive to the negative. Okay, so there will be 2 conditions to find the maximum point. Condition number 1, slope equal to 0. Condition number 2, slope, okay, the change in the slope is negative, right? Because at the maximum, before the maximum is positive slope, after the maximum is a negative slope. So the change in the slope is negative at the maximum point. What about at the minimum? Well, at the minimum, the slope equal to 0, but the change in the slope is positive, because it changed from the negative slope to the positive slope. So that's the idea, very simple idea. Based on calculus, right? The slope basically, how to calculate the slope? Slope equal to delta y divided by delta x. This is a discrete version, right? Okay. To calculate the slope, you need to calculate the change in x and the change in y at a certain point, right? If your delta x is approaching 0, then this will be a differentiation dy by dx. Okay? So basically, your slope equal to 0, it implies that dy by dx equal to 0. When you want the change in the slope equal to negative, that's the second derivative. The change equal negative, that means less than 0. That is your maximum. Okay, that is your maximum. Most of the time we just do this. Okay, the first one. First one is necessary condition. The second one is a sufficient condition. So how you do the derivatives here? So to make derivative easy, multiplication is difficult in your derivation. So we change multiplication into the summation. How do we change multiplication to summation? Take log. Because if you have x1 multiplied with x2, right? Equal to your likelihood L. Then you take log. Okay, log of x1 multiplied x2, what do you get? This is your high school math, right? So that's log of x1 plus log of x2. So that means the log likelihood here basically is the summation. Okay? So that's why after I take log, okay, this you still maximize the likelihood because log is the monotonic transformation. Okay, the point that maximize the likelihood will be the same point that maximize the log likelihood. So I take log, okay, simplify it here. And then this is the first order condition. I take a derivative, okay, set the slope equal to 0 and do a little bit of algebra. But the math confirmed that the theta equal to summation of x divided by n. I substitute the value 6 divided by 10. You get 0.6. Yeah, I'm not going through the algebra here, but you can go through it if you are interested. But the point is to show you that your objective is to estimate the theta. There are many ways to get the estimation. Yeah, there are many ways. Some ways is better than another. But the point is there are many ways. Okay? I already showed you the GMM, the method of moment. This is the maximum likelihood. The next one is the least square. So the least square is basically very popular based on the format of regression. So I can put this one in a regression format. And that is xi equal to the theta, just like thinking about it as an intercept. And then plus the other term. So this one is a problem without the slope. You only have the intercept. And you want to estimate the intercept here. In your least square, what is the idea of least square? The idea of least square is what is your regression? Okay? Once you are able to identify the regression, then your objective is to minimize the error term square. Okay, minimize the error term square. If you substitute the value of error term equal to xi minus theta. So you are trying to minimize this function. Okay? And how to minimize it? Take derivatives, right? I take a derivative, set it equal to 0. Again, I come up with the formula theta equal to summation x divided by n equal to 0.6. That's the same answer. So the point here is that the method of moment will give the same answer to maximum likelihood and the least square here. They all give the same answer. Well, only for this problem. For the different problems, sometimes they give a different answer. Okay? Sometimes some method is more efficient than another. In this case, whenever we talk about the estimator, okay, we need to understand that good estimator will have two properties. How can we tell that the estimator from MOM is good or is bad? Because there is a technique out there, right? You can do the technique to get the answer. How do you know that the answer is good or bad? Well, normally To know whether which one is better than another, we normally based on two criteria. The first one is whether it's the right estimator will be based on the technical term is unbiasedness. The unbiasedness. What does it mean, the unbiasedness? Well, it means that in the mathematics, you get your estimator, which is theta hat, okay? Theta hat is your estimator. Your theta is your parameter. What is the relation between parameter and estimator if your estimator is unbiased? The expected value here should be equal to the parameter. This is the unbiasedness. This is a condition that tell you whether you get a good estimator or not. Good estimator, because they are random variable, on average, they should be equal to unknown parameter. So it is a little bit puzzling because this is unknown. How do you know that it's equal, right? So in reality, we need to prove by the math. To prove this, we can't prove by the data. The data doesn't allow you to prove it because how do you measure something that is unknown? Okay, you can only prove this one in the math that the estimator is unbiased. And most of the time, these three, okay, they are unbiased, but sometimes they are biased. What about the efficiency? Keep in mind that the theta is random variable. Random variable means what? It means that the value is not constant, right? The value keeps changing. You may ask, I want to know the mean of the asset return. Why would the mean keep changing? Well, that depends on your sample, right? If you collect a sample 10 years ago, you get one mean. You extend it to 11 years, you get a different mean, right? When your sample change, the value of your estimator here will change as well. So efficiency will be normally measured in terms of the variance of your estimator. Those that have the minimum variance will be the most efficient estimator. The most or the best efficient estimator will have the minimum variance. Okay, you have the minimum variance among comparing different variants. This one we have the minimum. Okay. So keep in mind that whenever you do a technique, you need to keep thinking about these two. Are they biased? Do you get the best estimator? The best in terms of minimum variance. And most of the time, we use the least square. Because the least square will be, after it satisfies some assumption, it will be blue. Have you heard about the blue? Blue is an acronym. Well, what does it stand for? You never heard about blue? B stands for best, L linear, U unbiased estimator. So OS is blue, and the blue here captures two things: unbiasedness and its best. The term best implies that if you are comparing the variance of your estimator that come from the least square, it will be lower than any different way of estimation. Okay, it will be the lowest estimator variance in terms of the variance. So that makes it the best estimator. Of course, it must satisfy some condition. Okay, to claim that OLS is blue, there are some conditions. So this one gives you some perspective about different ways that we can estimate parameters. In any of your analysis, ultimately you need to estimate parameter, okay? And you need to have some techniques to do it. The most popular one is regression. And I would agree that regression is the best one. If it is suitable, some problem is not, then in that case you may need to use the GMM or the maximum likelihood. But if you have a choice and if the data satisfies some condition, you should start with the OLS. And that's why don't be surprised that OLS has been used a lot, okay, in all the research. Not because it's easy, but because it gives a good property. It is unbiased and it gives the lowest variance of the estimator. Okay, now let's go a little bit philosophical here. What is econometrics? So econometrics is the use of statistical method. Okay, but if it is the use of statistical method, why do we call it econometrics? Why just we call it statistics? Why do we need to call it different terms? What makes econometrics different from stat? You go to ask your friends who may be a scientist, they will tell you that, oh, I use stat in my analysis. But you use econometric. Why can't we just say we use stat, right? Because econometric is built on a stat. Do you understand why econometrics are different from stat? Or are they the same? Do you think they are the same or not? The answer is they are not the same because econometrics analyze non-experimental data. Why this is a big deal? Non-experimental. Why this is a big deal? Non-experimental, sometimes they use the term observational data. These are the data that you observe. Okay? You have no influence on that data. So, if you compare stat and econometrics, this is observational data. This is the experimental data. That's the key. That is the key. Okay? So you may ask why this is the key. Well, both of them try to analyze some regression analysis like this, y equal to alpha plus beta x plus the term. The same regression. But the difference is the variable x and y in the stat. Most of the time it comes from experimental. Why experimental is a big deal? Well, it is a big deal because by having experimental data, it implies the control environment. It means that you control every other thing else, and you only change the value of x, right? then you observe or record the value of y. This is experimental. You can control everything else, and you have a direct influence on x. You change the value of x slightly in order to see how the value of y responds. That's why sometimes they call the dependent variable y as the response variable. Because this is how y responds to the value of x that changed. So who changed the value of x? The researcher. You are basically playing God. Right? You change the value of x slightly, then see how the value of y change. What does it imply? It implies that you have a clear causation. Because x cause y for sure. How do you know that you have a causation? Well, because I control everything else. The only thing I change is the value of x. So as a scientist, very well, you need to make sure that when you say control, you really control. If you control it and you only change the value of x, then you have a clear causation, right? That x gonna cause y. Okay, x gonna cause y for sure. What is econometrics? Well, econometrics is observational. Observational means you have no influence whatsoever on the data. You only observe the data. For example, you look at the stock market return and interest rate. You have no influence on the interest rate in the market, right? If you want to analyze how the interest rate relates to the stock market, you go and collect the data, you observe them. You are not going to tell the Reserve Bank or Central Bank that, hey, let's change interest rate 1%, see how the market responds. Let's reduce interest rate 1%, how the market responds. No, no one can do that, okay? No one can do something like that. So, you only observe, okay? This one, you have a direct influence. This one you only observe. And all of the social science is using econometrics. Because they only observe. Okay, they only observe an event, only observe how things occurring. They cannot have an influence. They do not control. So this is when you have social science. This is the science. In the science, you have a laboratory to control it. In social science, you do not have a lab. Okay, you only observe the data. So, what makes it difficult here is the causation is unclear. This is only correlation. Okay? Whatever result that you get from here is correlation because you are using observational data. If you are using experimental data, then this is causation because you do experiment. Okay? This is the key that makes econometrics very difficult. Because you get regression result, you want to claim that this is causation. Well, the reader will say, hang on, now I'm not sure because it's just observational. How do you prove causation? Okay? That makes econometrics much more challenging than the science research. Okay? The difficulty of science research is to define or design this control environment. Okay? The difficult of econometrics is to analyze it, okay, to make sure that we get the causation, not correlation. Any question? Okay. So be careful, okay, about these causation and correlation, because whatever outcome from your regression, they are correlation. So you need a way to show that they are causation. If you can show that they are causation, moving from correlation to causation, we use the term identification strategy. Okay? So, when you run a regression, you get correlation result. You want to make a conclusion that this correlation result is a causation. To do that, you need identification strategy. Okay? And there are many strategies to do it. For example, you may use the experimental design. You may use the different approach, DID. You may use the other techniques, okay, the instrumental variable, for example. Yeah, there are quite a few. And we will go through some of the paper to show how they use different, or you can use the identification through heteroscedasticity as well. But there are quite a few ways to do that. But the key point here is econometrics, observation, step, experimental. Okay? Make sure that this is clear. So what is the objective of econometrics? Well, we try to analyze relation, okay, between different variables. We may try to forecast different variables. We may evaluate policy, whether this policy is good or bad. And the main research tool is your regression. Again, your regression, even though I say that result from your observational data is correlation, why would you bother with the regression? Why can't just calculate correlation? What is the benefit of the regression over a simple correlation? Even though, okay, I already told you that the result that you get from regression, you should interpret them as just a correlation. It means that causality is unclear. But why people still do a regression instead of just running a simple correlation? Okay. Why? So you have two variables, x1, x2, and then you want to see how x1, x2 have an impact on y. So the first approach would be calculate correlation of y and x1, correlation of y and x2. Right? You get correlation. Another one is to calculate the regression and most of the time people will tell you that, hey, the second one is the better one. Even though I already warned you that you don't go ahead of yourself too far. These are just the correlation results. But there's a benefit. What is the benefit? What is the benefit of regression over correlation? The benefit is the partialing out. In other words, it controls for other variables. The result that you see, better one here. Okay, and this is correlation between y and x1. I put it, say, R1. This is R2. If you are trying to compare beta 1 and R1, I have to tell you that the beta 1 is a better estimate. Because the meaning of beta 1 here is you calculate the impact of x1 on y when you control for x2. Okay? But if you just look at the correlation, well, maybe the impact of x1 also contains some portion of the x2 in here. So you are not so sure that these are purely x1 impact or there are some of the x2 impact as well. Until you do the regression, then you are certain that it's purely x1. Okay? For example, you look at this. Okay? Regression result, you take the difference here. So the intercept disappear. You get change in y equal to beta 1 multiplied with change in x1 plus beta 2 multiplied with change in x2. Because you control the change in x2, okay, the change in x2 equal to 0. In that case, you end up with delta y equal to beta 1 multiplied with delta x1. Okay, so that means this can be interpreted as the impact of change in x1 on y if there is no change in x2. Right? So that is the benefit of the regression over the correlation partially out. So that means if you do a univariate case between y and 1x, if there is only 1x, then it doesn't matter. If there is only 1x, correlation is the same as regression. If there are multiple x, then you would better off with regression because it partially out the other effect, the other x. Any question? Now, sometimes your regression may have a nonlinear term like x squared. Okay. Why would you include the x squared in your regression? What is the benefit? If you show this equation to maybe your niece that are studying in high school, what do they say about this one? A high school student, when they see this equation, what would they say? Well, I should rewritten it as a simpler term that you may be more familiar with. Y equal to ax squared plus bx plus c. What is it? What does it call?
Parabola.
Yeah. You should visit your high school teacher more often, so you'll be more familiar with this high school math, okay? We don't use a lot of advanced math. Mostly they are just a high school thing, but obviously we forget most of them. This is the, if you plot the graph, what does it look like? It probably depends on the value, positive and negative. It looks something like this, or maybe something like this, right? Okay. So this is parabola. Why we use this one in research? Why do we use this one in our research? Why can't we just use a linear function? This is a linear function, right? Mx plus c. So if you plot the graph, you will have a graph that looks like this. Okay? This is a linear function, mx plus c. C is your intercept. What is the benefit of parabola relative to linear? Well, you see the difference? You see the difference, right?
One of them's a line on the curve. I'm not it. What do you mean by benefits?
The benefit means that can't we just use a linear function? Why do we need to rely on the parabola or the quadratic function?
Because there's a point in which the slope is 0 in the parabola.
Of course. But in terms of the application, what application that is more suitable by using the quadratic function? You see the characteristic of these two graphs, right? It is not because one is linear and other one is a curve. That's not the benefit. The benefit here is that if you use a linear function, the relation of y and x always have one relation. That is either it's going up or going down, regardless of the value of x. Only have one type of relation. If you use the parabola here, relation of y and x can have two relations. Sometimes it's go up, sometimes it's go down, depending on the value of x. And the value of x could be a critical point. Okay? Now, why some research may use the quadratic function? Well, because sometimes even the relation can change, right? So what are examples of the change in the relationship, okay, between x and y? So I can tell you something like the capital structure. What do you learn in the capital structure? You learn corporate finance before, right? Or financial management. So what is the theory about a capital structure? What is the textbook going to say about a capital structure? Well, most of the textbook basically start with M&M. Who is M&M? M&M are basically the two Nobel Prize winners, okay, Modigliani and Miller, okay, Modigliani and Miller. So what is M&M actually says about capital structure? Merton Miller is the father of modern finance, okay, because the idea of capital structure theory that he has is based on no arbitrage. But the idea is very simple. Like the most important idea is simple. It's just like a pizza. You eat pizza before. So we can represent pizza as a firm value. And capital structure is how you cut the pizza. So you may cut the pizza in this way. Right? And you call this one equity, and this one is a debt. Or you may cut the pizza in different ways. The same pizza, you may cut it half and half. But why would we worry about cutting the pizza here? Well, cutting the pizza is the financial decision of the CFO, right? How do you structure your capital? How much should you borrow? How much should you use your own money? What is the objective? Objective here is to maximize the firm value. And looking at the pizza and how the way you cut it, can you increase the size of the pizza? No way. Regardless of how you think about cutting the different ways of the pizza, there is no way that the size of the pizza is going to grow or shrink. So in this case, what is the idea of M&M? Irrelevant, right? Capital structure decision is irrelevant. Well, because no matter how you cut the pizza, it's not going to change the size of the pizza that is a firm value. So For the CFO, don't waste your time and energy thinking about capital structure decision. Doesn't matter. Well, this is what we call the theory. And anything that is theory is based on some assumption. Okay, the theory is valid only when assumption is valid. What is assumption here? Assumption here is the frictionless world. I'm not saying that the theory is wrong. The theory is valid. But what is wrong is the world is not frictionless. There's a lot of friction in the world. Okay? Now, in the capital structure, one of the biggest friction is tax. Okay? And anyone who study accounting knows that tax is a big thing in the corporate policy. So why tax matters? Why tax matters here? Well, tax matter here because if you use debt, you pay interest, and you can use that interest to reduce tax payment, right? The more debt you use, the less tax payment, okay? So if you allow the tax to play a role in the capital structure decision, and it does play a role because in the real world we have tax here. We have corporate tax here. What will be the optimal capital structure? When you have a tax here, it means that part of the pizza is no longer two parts, debt and equity. Another part here is tax. And who gets this piece of pizza? The government. The government gets the pizza. So what is left for the corporate will be smaller, right? So the idea would be, okay, can we increase the size of the pizza for the shareholder? Yes, we can. How? How would you increase the size of pizza? Well, the idea is pay less tax as possible, right? How? Maximize the debt. Maximize the debt because having debt reduce tax payment, shrink this part of the pizza. So ultimately, yeah, try to minimize tax payment by increasing the size of debt. The optimal solution is 100% debt. Okay, 100% debt. But do you see any corporation use 100% debt? No. So what's wrong? Well, we talk about the frictionless world, right? And we already introduced tax as one of the friction. In the real world, there are more than one friction. What are the other frictions? If you are the lender and the firm say that, oh, I'm going to use all of the money from you. I want to borrow everything from you. Are you going to lend them the money? No way. Why? Well, because you're concerned about the bankruptcy cost, right? You're concerned about the bankruptcy cost. So that is another friction. So these are the bankruptcy costs. So that's the idea, okay? You try to maximize the part of the pizza available to the corporation, the shareholder. And there are two major friction, tax and bankruptcy costs. If you look at tax, you need to increase debt. Okay, debt go up. If you're concerned about bankruptcy costs, debt should go down. So you can see that there are two opposite forces. Okay, that the CFO needs to decide about the structure of their capital. And this comes to the idea of the trade-off theory. So what is a trade-off theory? Well, basically, this is a trade-off between tax and bankruptcy costs, right? So that means if you look at the capital structure, the level of debt to total asset, okay? So the horizontal line is between debt to total asset, and that's the firm value. Most of the time, you're gonna see something like this. Okay. So when you this one increase the debt, okay, increase the debt, and the firm value also increase. This part here increase the debt, and the firm value decline. Okay. So this part because of the tax shield. Okay, tax shield means that this is a tax reduction because you pay interest from the debt, you use it to deduct your income. These are the tax shield. Increase firm value, pay less tax. These are bankruptcy costs. Basically, it means that, hey, you borrow too much, okay? The more you borrow, the lower the firm value, okay? The lenders start to get nervous. The lenders start to have a sleepless night. So they're probably going to charge you a higher interest to cover their risk, okay, or to pay for the insurance. So that's a theory. What I tell you is a theory. I'm telling you that these are the theory. We only consider two friction, okay? Now, as a researcher, what do? As a researcher, you should keep questioning. You need to keep asking, is this a right theory? Can I prove it? How do you prove that the trade-off is actually what happened in the real world? Is it true? Okay. How do you prove it? So you prove it by running a regression between the firm value, right? And the capital structure, debt to asset. That would be your specification. Why you use the specification like this? Well, because there are some period that the value go up, another period the value go down. So that will fit into the quadratic function. Okay. So you need to collect the data, okay, estimate this regression. How do you find a support to the trade-off theory? What sort of result that would lend support to the trade-off theory? What sort of result you are looking for? For the trade-off theory to be valid, it needs to go up at the beginning and it needs to come down at the end, right? And that would depend on which parameter. If you look at the parabola function, you can have two different parabola, right? You can have a parabola that look like this, or a parabola that look like this. Okay? It depends on which one. Y equal to ax squared plus bx plus c. It depends on which parameter, whether it's go like this or like this. It depends on A. This one is a positive A. This is a negative A. Okay? So what you need is a negative gamma. Okay, so that means if you are interested to test the trade-off theory, you would say that if the gamma is negative, then okay, we support the trade-off theory. So that's the conclusion you are looking for. So that means when you write your proposal, okay, you should go through the step that I outlined to you. Okay, the step would be first, think about the theory first. The theory normally based on the rational thinking, okay, or the literature. And then you design your techniques here. Okay, the techniques need to fit your problem. Don't just blindly use the regression. Okay, in this case you need the square term because it's up and down. Okay, that's why the square term is useful. And you need to anticipate your result. Okay? If you want to find evidence that supports your theory, what would it look like? This one gamma should be negative. If you find gamma equal to 0 or gamma is positive, then there is no support for the trade-off theory. Okay? Any question? But it doesn't mean that trade-off theory is the only theory for the vector structure. Do you learn about any other theory? What are the candidates for the alternative? Everything has alternative, right? In this case, one explanation is a trade-off. What is the second story about the capital structure? The second theory is what they call the pecking order. What is a pecking order? Have you heard about pecking order? No? Yes. Yes. What is it? Yes or no? Yes, right? I hear yes here. What is a pecking order? The pecking order is a hierarchy. Who is the boss, right? This is a pecking order. So in this case, that means there is a clear hierarchy of how the funding going to be used. And the pecking order make a prediction that, look, the firm, okay, if they want to spend the funding or raise the capital, what they go for is retained earning first. That is the retained earning first. That is the first priority. They use it first. If they burn through the retained earning, then they go for the debt. If they borrow to the maximum, okay, or the cost of debt is too high, then they go for equity. That is the prediction of pecking order. Okay. And why the prediction look like this? Why don't corporate use equity first? What is the rationale? Why they go through the retention? The pecking order here based on the idea of asymmetric information. What is asymmetric information? Have you heard about this term before? What is it? What does it mean, asymmetric information?
One party has more information than the other.
That's right. Okay, one has more information than the other. So in this case, we are looking at insider and outsider. Insider know about the firm, right? And outsider know less about the firm. So let's assume that the firm have a good, positive NPV project. Okay, so they need the capital to invest into that project. Now they will ask, okay, how should we get the money? Well, if we have the cash in our account from the last year retained, and then use it first. Why? Well, if you consider the alternative, let's go to the market and issue the season equity offering. It's just like, okay, you have a friend, okay, and a friend comes to talk to you, hey, I have a good project, lend me $1 million, and I give you a share of 25%. What do you think? Well, you will say that, okay, if it's a really good project, you as the owner want to keep it to yourself, right? You only going to share the ownership if you can't get any other things, okay? If you really can't get it. But if you still can get from your mom and dad or your bank account, you're going to do it first, right? So then that's the same, because the outsider, they don't know about the prospect of the funding of the project that the firm will use. So if you start and asking for equity, then you're going to get it at discount. You need to provide a substantial ownership, okay, to your friend to convince them that that's enough for them to take the asymmetric information risk. So that pecking order have a different prediction altogether. Okay? And as a job of your researcher, as a researcher, that if you test the trade-off theory, you should think about the alternative. Okay, whether the alternative is true or not. Any question? Another application that people use in the quadratic function is the agency cost. So what is agency cost? Have you learned about that? Agency cost? Did you get a term? The agency cost is the misalignment of the incentive. That will create agency cost. Well, in the corporate world, who is the owner? Shareholder, right? What is the objective of the shareholder? Maximize the shareholder value. But shareholder has no skill in managing the business. Shareholder has money, but has no business skill. So shareholder get the CEO, okay, to manage the firm. What is the objective of the CEO? No. Maximize their own wealth. Right? We are selfish. The reason why CEO try to maximize the shareholder because of a contractual benefit. Okay? There is a contract that forces them to maximize the shareholder value. But without a contract, then CEO try to maximize their own benefit. That's why you see that CEO misspend the money. You heard about the case of this son, right? The CEO used the corporate money to buy a jet, to buy a vacation, and so on. That is the agency cost. How do we solve the agency problem? How do you incentivize the CEO to work very hard to the shareholder? So you need to align the incentive, right? And as the owner, incentive is maximize share value. And you should give them a contract similar to Steve Jobs, where you get $1 an apple as the fixed salary. The rest are the option on the share. Okay? Give part of the share, okay, stock to the CEO. Okay, so that CEO have the substantial wealth in the stock, the same as the owner. Okay, so they align the incentive. Now, in this agency cost, this again per value. This is a percent of the share held by the CEO. So CEO is part of the shareholder. Okay. So the idea is that the more holding in the firm, okay, the value of the firm should go up. But thing is not that simple. Okay. Even though you have the same shareholder, okay, you still try to fight among the shareholder, right? And you might hear that the shareholder, some of the major shareholder, they do the tunneling. What is the tunneling? The tunneling is the way that the major shareholder expropriate the wealth of the minority shareholder. You and me, we are minority. You go and buy stock, you are basically the shareholder, but you are minority. You are not a major shareholder. So there is an agency cost between you and major shareholder. And the major shareholder try to handling the wealth of the firm, okay, to another firm that they are the owner, but you are not. Okay, so that is a handling. For example, they may buy something expensive equipment, and the seller of that equipment is that firm. So they tunnel the wealth of the firm to another firm. Okay, so that is also the agency cost. So if the CEO have an incentive aligned with the shareholder, well, at the beginning, they will try to maximize the value. But once they start to have a substantial holding such that they can have a major say at the board of directors, they can have some control of the firm, you will see that the firm value may decline. This is, the first part is to align incentive. Because you align incentive, then the firm value go up. But the second part here, the firm value go down because of the entrenchment. What is the entrenchment? By the entrenchment, entrenched CEO basically think that they are not the employee. Basically, anyone who works for the firm is an employee. Once you start to have a substantial holding, you think that you are the owner too. This is my company too. And, well, I can control the company through some of the directors. Then I'm going to buy a corporate jet. Okay, I have a private jet. I'm going to have a holiday boat. I'm going to change my compensation package and so on. So these are the entrenched CEO. Okay, so because they have a control, these entrenched occur because they have a control. Okay, they have a substantial control. Then they use that control to maximize their own benefit. So if you want to test this sort of a story that is the optimal point of the CEO holding. So you want to find this optimal point. how do you find this optimal point? Then you can run a regression between firm value, holding, okay, and the holding square. So you believe that there would be an optimal point, okay, in terms of the share ownership for the CEO. How do you find this optimal point? To find this optimal point, you need to do a calculus, right? Take a derivative of this one after you estimate the regression. You take a derivative here. So dB by d of the holding. What do you get? First term disappear. Okay. Holding, you get beta 1, right? And then holding square, you take down the 2. Okay, that is plus 2 beta 2 holding. And then you set them equal to 0. So the optimal holding, okay, that maximize the firm value, holding square will be minus beta 1 divided by 2 beta 2. That is the optimal holding. Okay? Optimal CEO holding. So if you are interested in CEO compensation, this is one area of research that is very popular. Okay, what is the best way to compensate a CEO? To reduce their agency cost, to incentivize them to work very hard for the shareholder. Okay, and you can start by a simple theory in terms of agency cost and control. Any questions? Okay. So that is part of this one quadratic function. So you can see several applications in the different types of research. Okay, capital structure and compensation. Another one is the log function. Okay, the log function. So sometimes the variable of interest, we don't use y, okay, but we use the log of y. What is the benefit of the log of y? Why do we take log? When you run the analysis, why would you take log? Well, I can show you the benefit here. If I show based on the spreadsheet, one of the benefits of the log would be to reduce the impact of the outliers. Let's say these are the variable x. We start with 10, 100, 20, 100, and 1 million. 1 million is 10 to the power 6, right? That is 1 million. And if you take log, I use natural log. Log of x. This should be ln x. So these are the natural log of x. So what do you see here? If you run a regression and one of the observation is 1 million, when all other observation is about 10, 20, 100, that 1 million gonna skew your result a lot. This is a clear outlier. Okay? But when you take log, log basically will shrink the impact, okay, of the x. This serves as the shrinkage parameter. So that from 1 million, that becomes 13, and that is very not too far away from the rest. Okay. So log has a benefit in terms of reduce the impact of the outliers. The second benefit, and probably this is why it is quite important, is log will help you to interpret your result. In the regression with log, it is quite easy, okay, to have a good interpretation of your result. Now, what does it mean by a good interpretation? For example, you are running a regression between the y equal to 1.2 plus 2.1x. Let's say this is your analysis result. Okay. Now, can you interpret them? In this result, can you interpret them? Interpret them, it means that can you tell a layman people about your outcome here? Well, so you can say that if, because we don't specify what is x and y, so we are general here. If x, okay, increased by 1 unit, the impact on y will be that the value of y will increase by 2.1 units, right? Okay, that is how you normally interpret this result. Okay. So if I generalize this regression again, y equal to alpha plus beta x plus 0 term, it means that if x go up 1 unit, y will go up by beta unit, right? Okay, that's how you interpret this result, isn't it? But how do you get this interpretation? Well, I can show you that you can get this interpretation because you assume that this is y1 equal to alpha plus beta x1. And then you look at another point, y2 equal to the same parameter. Keep in mind that parameter here is constant, x2. So you have equation 1 and equation 2. You use equation 2 minus equation 1. So you get y2 minus y1. And the alpha disappears. So you get the beta, okay, x2 minus x1. So that means if x go up 1 unit, okay, that means x2 minus x1 equal to 1. So y2 minus y1 equal to beta. So that means y go up by beta. Right? That's how I come up with this interpretation. Okay. But the problem with this one is, okay, we say that x go up by 1 unit. But probably we don't know whether 1 unit is a lot or not. It depends on the unit of x, right? If the value of x is very small, then 1 unit is a lot. If the value of x is very large, in 100 or in 1,000, then 1 unit is small. Okay, so we don't know about the size of the impact, whether it's a big impact or it's a small impact. So the better way to look at it would be to use the log. Okay, to use a log. For example, if we have run a regression log y equal to alpha plus beta log x, what is the interpretation of the beta here? Is Is that the same one unit increase in x and the beta unit increase in y? No, it's not. So to understand how to interpret this one, let's say that we have 2 points again. Log y2 equal to alpha plus beta log x2. And then log y1 equal to alpha plus beta log x1. This is equation 2, this is equation 1. So 2 minus 1, what do you get? So you get log y2 minus log y1 equal to beta log x2 minus log x1, right? Okay. Now, what is the meaning of log y2 minus log y1? You know the meaning? Do you learn about the time value of money? You know about that, right? So in the time value of money, if you have deposit your initial value, okay, V0, you get the interest rate 1 plus R. You compound that, okay, to the power t. So that will be the value of your VT, right? Okay. So this is the time value of money, and you compounding. Now, how frequent you compound? You compound every 1 period. Okay, let's think about it in terms of the year. If t equal to say 3 years, so that you compound at the end of year 1 and at the end of year 2, right? And at the end of year 3. So if you compound continuously, this is the discrete compounding. If you do the continuous compounding, or maybe say the monthly compounding, how does it work? If you do the monthly compounding, what is the value? Do you remember the compounding? Instead of compound annually, you compound every month. Would you get more money? Yes, you would get more money, right? So if you compound every month, that will be V0, 1 plus R divided by, well, okay, R is interest rate per year, and T will be multiplied by, well, that would give you the VT, right? That's compound every month. If you compound every second, or every millisecond, that is what we call continuously compounded. So that means the period that you compound, say R divided by N, okay, and T multiplied by N. If the value of N approaching infinity, okay, that means you continuously compound your interest. You learned about this one before? If you continuously compound your interest, what do you get? Vt equal to V0 exponential RT. Right? That is in exponential. That is a continuously compounding formula. Now let's say that we look at 1 period, 1 year only. Okay, but we continuously compound within a year. So if t equal to 1, then V0 multiplied with ER equal to V1, right? Then if I do a little bit of manipulation, so ER equal to V1 divided by V0. How do we bring down the R? take log. We take log on both sides, we bring down the R. So R here equal to log V1 divided by V0. Right? We take log on both sides. Log of exponential R. Log cancel out exponential. You have only R. And that is log of V1 minus log of V0. Okay? Log of V1 minus log V0 equals to your R. What is your R? Your R is the percentage change, right, in your capital. Now go back to the question that I asked you before. I asked you about what is y2, log y2 minus log y1. What is it? This is the percentage change of your V0 to V1, right? This would be percentage change of Y. Log Y2 minus log Y1 is percentage change of Y. Log X2 minus log X1, this is percentage change of X as well. Okay? So that means we can now interpret this one. It means that if X go up 1%, Y would go up by beta percent. By making it percentage change, that is easier to interpret the result. Because you don't have to concern whether X has a big unit or a small unit. It's all relative in percentage. So that's why taking log is very convenient. Okay? It helps you to interpret your result. Any question? Okay. All right. So I summarize some of the different specifications here. You can read it by yourself. Okay, these are the, if you have the log on both sides, log y, log x, x increase 1%, y increase beta percent. If you have only one log in y and x has no log, then the one that has no log you need to interpret as x increase 1 unit and y increase equal to 100 multiply beta percent. In this case, for example, if you get the result that look like this, log y equal to 1 plus 0.02x plus the other term. The way you interpret here is if x increase 1 unit, okay, y increase by 100 multiplied with beta percent. That is 2%. Okay? And another one is log is on the y-x side, y equal to 2.4 plus 12.1x. So in this case, if x, log x. Okay, whenever you see the log, that is related to the percentage change. So if x increase by 1%, Yeah, percent, not unit. Then y increased by beta, that is 12.1 divided by 100 unit. Okay, that is equal to 0.121 unit. Okay, so that's how you interpret this result. Any question? We talk about the estimation a lot, okay, and after you estimate the parameters, you need to do the hypothesis testing, and there are 3 different ways to do the hypothesis testing. Okay, the first one you calculate the t-stat. Okay, the second one you calculate the interval estimation of your parameter. So, for example, the t-stat, I think you are pretty well known, right? T-stat equal to the beta hat divided by standard error of beta hat. So, and then you look at the t-stat, whether the t-stat is, say, less than 1.96. If the value of t-stat less than 1.96, then you accept the null. Okay, at 95% confidence level. Right, let's say you do it 210. Okay. Another way, the interval estimation is you calculate the upper bound and lower bound. Upper bound of the beta hat will be the beta hat, okay, plus your critical value 95%. Okay, multiply with the standard error of beta hat. Okay. So in this case, it would be beta hat plus 1.96 multiplied with standard error of beta hat. That will be the upper bound. Okay, because the beta hat is the random variable. So the upper bound here, given 95%, will be beta hat plus 1.96 multiplied with standard error. And the lower bound will be beta hat minus critical value, okay, multiplied with standard error. That will be beta hat minus 1.96 standard error of beta hat. And the way you test the hypothesis is to see whether the upper bound and lower bound cover the zero. Let's say this is your lower bound, this is your upper bound. Okay? If the range of your upper bound and lower bound is outside, is not cover zero, then you reject the null. Okay? Then you reject the null. If the range cover the zero, this is the lower bound, this is the upper bound, then this one you accept the null. Okay? So that is your interval estimation. And the next one, the last one, is the p-value. Okay, how do you use the p-value? Well, the p-value is probably you need a computer to calculate it. Basically, you assume that the beta follows some certain distribution, maybe normal distribution or t-stat. And then you calculate the t-stat here. The area in the tail. Okay, if it's 2 tail, then you need to count 2 areas. These 2 areas equal to your p-value. Okay? It should be symmetry to get a t-stat. If you look at the 2 tail, okay, sum of it should be the p-value. Okay, and the p-value less than 0.05%, then you reject the null. Okay, greater than 0.05, then you accept. So that depends on whether you use what confidence level. Okay. Any question? So this is I think something that you know, but just want to refresh. And talk about the significant, you should always discuss whether they are economically significant or just the statistical significant. Okay? The economic significance it depends on the size of the beta. Okay, sometimes the size of the beta is big, then that means that it is economically important. Okay? Size of beta is large, then this is imply that X has a strong economic impact. Okay, on Y. Okay, so these are the economic significance. Right, so economically significant, we rely on the size of the data. So when you interpret the result, it's quite important that you do not stop just saying that X is significant or not significant. It is always meaningful to interpret that if the value of X changed by a unit, what is the impact on Y? Okay, and that is what we call the economic interpretation. Okay, so it should always come together. Now, if you do any hypothesis testing, you will have an error. Okay, that there are no perfect tests. You're gonna have a type 1, type 2 errors. Okay, so what is a type 1 error? Type 1 is what we call the false positive. The false positive. You reject the null when the null is true. Okay, that is the type 1 error. And the type 2, false negative. Okay, so type 1, false positive. Type 2, false negative. And just like anything in life, there is no free lunch. Okay? So you can design a test that maximize the power, okay, or reducing the type 2. But that test is gonna have a weak type 1. Okay? So type 1 and type 2 normally is sort of a trade-off. Okay, the trade-off between type 1 and type 2. So I give you one example here where we look at the case of the hospital analysis diagnostic. So let's say you have 1,000 patients, okay, and they are testing whether they get a cancer or not. In these 1,000 patients, some of them test positive, some of them test negative. Test positive means that they detect, okay, some indication of the cancer. So let's assume that out of 1,000 people, 110 detect, okay, indication of the cancer. Okay, so 110 is what we call the positive test. And the rest, 890, that gives you a negative test. Okay? Now, within 110 that get a positive test, some of them develop the cancer. Okay, that confirm the diagnostic. So let's say 11 of them develop the cancer in the future. Okay? But 99% is not. So even though you test positive today, but 99 people out of 110, in the future they are okay. They do not have any cancer in the future. So in this case, this is what we call a false positive. You test them today, okay, and you think that they're gonna have a cancer, but in the future they don't. they don't have a cancer. This is a false positive. Okay? And this false positive is what we call the type 1 errors. Okay, the type 1 errors. Now look at the second case. When you do the test today and you tell them, oh, you are okay, go back home, have a good sleep. In the future, 3 of them develop a cancer. Okay, even though the doctor tell them that you are okay. So that 3 people, this is what we call a false negative. So that means that you test it today and the doctor said you are okay, but in the future you are not. That is a false negative. That is the type 2 errors. Okay, that is a type 2 errors. So as a doctor or as a researcher in the medicine area, you want to minimize both cases, right? You want to minimize the type 1 and type 2 errors. And this is serious. Okay? This type 1 and type 2 is serious. But which type is more serious? Well, in this case, you would say, oh, type 2 would probably be more serious because you think that you don't have a cancer and that's why you do not live in a very healthy way. Okay, so that's probably more serious in this case. That type 2 is something that you need to work on. And type 1 is also serious because if you tell that someone got a cancer, you probably put them in a prison, right? They have a very depressed hearing the news. So anyway, in both cases, they are serious, but from the medical point of view, type 2 is more serious. Okay? Any question about the type 1 and type 2 errors? So how do we reduce the type 1 errors here? Do you think how do we reduce the type 1 error? To reduce the type 1 error, you normally increase your confidence level. Okay, for the test to tell that this is positive, you are not going to use 95% confidence level. You are going to use something like 99.99% confidence level. Okay, if you keep increasing your confidence level, you can reduce the type 1 errors. Okay, you can reduce the type 1 errors. How do we reduce the type 2 errors? To reduce the type 2 error, you need to develop the more effective test that can detect the disease better. So this is a technological question, whether you can develop a more powerful test. Yeah, that is to reduce the type 2 errors. Any question? And I have to say that in real life, sometimes type 1 is more important. Okay? Sometimes type 1 is more important than type 2. For example, you look at the murder case. What is the philosophy of the judge? If you need to decide whether a guy commit a murder or not. Well, the philosophy would be you'd rather let the wrong people walk away than put innocent one in jail, right? You let 1,000 wrongdoers walk away. That is better than putting one innocent people in jail. Okay? So in that case, in the eye of the law, okay, they try to minimize type 1. Okay? Now, in some of the research, okay, I have to say that there is a type 3 error. What is type 3 error? Now, if you read the textbook, there is no type 3 error. Type 3 error is something that I think you should be careful about research. That is getting a perfect answer, okay? type T error is you get a perfect, accurate answer for an irrelevant question. That means you have no contribution. Okay? In research, you commit type 3 errors when you are doing a topic that is not important, it's not interesting, no contribution, that is a type 3 error. Okay? So this is probably very important, the most important errors that you should be careful. Okay? Getting the right answer for the wrong question. Doing research is asking the right question. Okay? I emphasize several times. It is about asking the right question. Well, I think I just skipped this one. These are the standard assumption, okay, of running the least square. And one assumption is the beta must be linear. Okay, if you have the beta that is nonlinear, then that means it's violate this assumption. Nonlinear beta looks something like this: y equal to alpha plus beta 1 x to the power beta 2. The beta 2 here is nonlinear. Okay, if you have a specification that looks like this, then you violate the first assumption. In the second assumption, the way you collect the data, okay, must be random. Okay, the data that you have should be random and represent a population. That is what we call the random sampling. Okay, the random sampling. And the random sampling is quite important because if you don't understand the nature of your data collection, your conclusion is wrong. One example is several years ago, okay, probably a decade ago, the World Health Organization, they are trying to improve the health of the pregnant women in Africa. Okay? And to do that, they developed a pregnancy program for the women in Africa. Okay? And they allow the women to join the program and they measure, okay, the effectiveness of the program by the childbirth weight. Okay? If the childbirth weight is high, then that normally implies that the health of child is good. Okay? So the program is successful. So to measure the program effectiveness, so they use the childbirth weight. Okay? And then run a regression with the dummy, the binary variable, whether the female, okay, the pregnant female join the program or not. Okay, that is the simple regression. So what would they expect? They would expect that the beta should be positive because the variable join here equal to 1 if a pregnant woman join the program, and equals to 0 if not. Okay, so that's how they develop the research framework. So they would have thought that the beta should be positive because this program is good. They provide knowledge, how to prepare yourself, how to eat a good food, appropriate vitamins, and so on. And this is the framework. What is the outcome? After they develop the program for a few years, they collect a sample and this is the outcome. When they collect the data, estimate the regression, the outcome is that the beta is negative. So if the beta is negative, what does it mean? It means that for a pregnant female, pregnant woman who joined the program, their childbirth weight has gone down relative to those who do not join the program. Okay. Now, the question is, what is wrong this whole thing. Is that the program is bad, that is not only improve the health of the pregnant woman, but it's also make it worse? No, that should not be the case, right? The program should improve it. What is wrong is the way we specify and interpret the result. And what is the reason why the beta health is negative? It comes from what we call the self-selection problem. Have you heard about the self-selection problem? And if you do any research based on the survey, yes, you need to be very, very careful about self-selection problem. And the reason for self-selection here is that who's going to join the program? You think about it, okay? You're pregnant, let's assume you are female, you're pregnant. The government offers a program to you, okay, that's going to take care of your health, your baby. Would you join the program? Well, the answer would be depends, okay? If you can afford the medical by yourself, you probably don't need a government help, right? Because you can go to the private hospital, you get the food treatment anyway. You don't need a government one. So, this highlight the self-selection. The negativity of this result is not because the program is worse, but because those who do not join the program, they come from better sociology family. Okay, they have more resources to take care of the baby. And it has nothing to do with whether the program is effective or not. Those who are more wealthy, they get a better health. Okay? And those who are poor self-select themselves into joining the program. So those who join the program is because they are poor. Okay, so it cannot be used to measure effectiveness of the program. Okay, this is a self-selection. And self-selection is so progressive. For example, one of the great debates in education is, does public school worse than a private school? Which type of school provide the best education? Well, you may have, or you may throw in a bilingual school. Okay, do you think international bilingual school provide a better education than a public school or than the native Thai school? How would you answer this question if you try to answer? Well, you might say, okay, let's have a look at their GPA when they have some sort of a standard test. Okay, maybe everyone needs to do an entrance exam. I don't know whether you have entrance exam now, but in my time there are. Okay, so let's look at the entrance exam. An average, who has the highest average, that's the best school. Okay? But I would say that's not fair. Why? Well, because do you think who joined the bilingual school? They are kids from the wealthy family, right? And because their family is wealthy, they can afford to provide extra, okay, things, extra resources to improve their kids' education. It has nothing to do with the school. Okay, it's about the resource that parents have. So this is also part of the self-selection problem. If you are not careful about self-selection, you get the wrong conclusion. Okay, so a lot of research question, you need to think deeper, okay, whether this is some sort of a self-selection, where there are some omitted variables that you haven't considered, especially the school may not have a great influence as much as the resource of the parents. Okay. Any question? All right. The next assumption in your OLS would be the collinearity, no more perfect collinearity, and I have to emphasize on the perfect. So that means the perfect is correlation equal to 1. Okay, and as long as the correlation between x is less than 1, you can still run a regression, and this assumption still satisfied. Okay. The fourth one is the zero conditional mean. And it means that the conditional mean of error term at x equal to 0. Now this is quite important. This is probably the most important assumption. Okay, because this assumption is normally called the exogeneity assumption. Expected of error term conditional on x equal to 0. This is similar to the covariance of error term at x equal to 0. Okay, it implies that. In other words, it implies that the error term and x, they are not correlated with each other. Okay, there's no correlation. The violation of this assumption is the endogeneity bias. Okay, if you violate this one, you have endogeneity biases. Have you heard about endogeneity bias? Okay, so that is a serious problem, okay, in our endogeneity problem. The first four assumptions, okay, and the fifth assumption is what we call the homoscedasticity. You heard about that? Homoscedasticity. What does it mean, homoscedasticity? It means that the variation, okay, of the error term is not depending on x. Okay, variation of the error term is constant. You notice that the variance has no subscript, so that is a constant. The variance of the error term is basically constant. So what is the example of the heteroscedasticity? Okay, heteroscedasticity is when the error term variance is not constant. For example, you could have the regression where you look at income, okay, and the education. So this is something like a return on education question, okay, or maybe you can look at it in terms of the CEOs. Okay, whether CEO who get, say, a PhD would earn more or less than the CEO without a PhD. Okay, whether some accreditation like the CFA add values, okay, for your lifetime earning or not. So this sort of question, return on education, you would have expect that the relation between income and education should be positive, right? Because that's the whole point, that having education is to improve your lifetime income. Okay. Now the problem here is that this sort of question, you will have the hetero problem. I can tell you now that without even look at the data, if you are doing the return on education type of research, you have a hetero problem. How can I know? I haven't looked at the data. How can I know that you have a hetero problem? Well, I can use some logical argument here that the hetero problems occur when the variance of the error term is not constant. It is not constant across x. Okay. So that is part of the hetero problem. Now, how do I know that? the error term, what is the information contained in the error term? When you run a regression, you have the error term. What sort of information contained in the error term? You see an equal sign, right? Income equal error term. So part of the income information will be contained in the error term. Okay, the other part is controlled by the education. So you can look at the error term as the income control X. Okay, after you control for education, okay, what is income? So what do you think about the education impact on the income? If you don't have education, okay, you have minimum education, what is the chance of getting a high income? Fine, it's low. But some get that high income, right? Become entrepreneur, become successful. And some don't have education but need to get a minimum wage, not successful. So there's a huge variation in terms of the income if you don't have education, right? You can end up a billionaire, successful in business, or minimum wage. But if you get a PhD, you probably become working in a university just like me, okay, or some sort of an institution. Well, you get a relatively high income, but well, it's going to be quite limited. Okay, the band that you get maximum and minimum is not going to be too different. Okay, so you see that this has a high variance of error term. This is a low variance of error term. So this problem always have the heteroscedasticity problem. Okay, so some of the problems you can sort of see by the analytical thinking that, okay, whether the variance of your error term will vary, okay, based on X or not. In this case it is. Okay, one thing that after you do the estimation, okay, we need to calculate the standard errors of the estimator. And it's important to know that whether your estimator is best, okay, what we need is the unbiased. And what we need is the best estimator. The best estimator is the minimum variance of the data. Okay, that's what we discussed before. Okay, the two ingredients of a good estimator is unbiased at best. Best in terms of the minimized variance of the estimator. So if you look at this formula, whether you get the best estimator or not depend on three things. First, it depends on your sigma square. Okay, what is a sigma square? Sigma square is the variance of error term. And as I said, the error term is part of your dependent variable. So variance of error term is going to be high if your dependent variable have a high variation. Okay, so if your y, okay, if the variable that do not fluctuate a lot or some sort of predictable, then your estimator normally get the best, okay, estimate. You should get a very small standard errors. Okay, in this case, small or lower standard error of beta hat. Okay, if these three conditions satisfy. What is the second condition? Total sample variation of X. The first one is variation of Y. This is high variation in X. So that means the X you need to get from a variety of X. Okay. For example, if if you want to look at income to education, you should get a sample from people with different education. Okay, from very high education, intermediate, okay, and low education and no education. If you can get a high variation in X, you can reduce the errors of your estimation. But you need to have a low variation in Y. Okay? Low variation in Y, high variation in X. What is the last one? This one is interpret easily as the no relation between X. If you have 0x, x1, x2, x3, your correlation among the X should be 0. Okay? If you have a 0 correlation between the X, that will reduce the standard errors of your estimation. What it means is that when you have no relation between X, it implies that each X can provide unique information. Okay, each of the X can provide unique information into understanding Y. And that will reduce the standard errors of your estimate. I think I stop here for now. Okay, I forgot to take a break. We will have a break in the afternoon. So let's take a lunch break. Okay, and then come back one.